This is our project Lufa disease detection using deep learning, where we are going to see the model we have trained to see how we can detect the Lufa disease. So, first of all, let us see what is exactly a Lufa disease. So, Lufa disease is a serious disease that affects the leaves and fruits of plants in Cucurbita genuses, which include squash, zucchini, cucumbers, and pumpkins. It is caused by the particular fungus Physimythomyces and is characterized by yellowing, wilting, and defoliation of the leaves, which can ultimately lead to fruit loss and yield loss. This is a serious disease which is sometimes ignored at a very large rate. Our problem statement was to develop a deep learning model for the early and accurate detection for Lufa disease in cucurbita plants, where we aim to identify and classify the disease symptoms caused by this particular fungus so we can help in timely intervention and prevention measures. So this way the farmers can also save their crop for the better. So our solution approach is that we will develop a convolution neural network technique model where we will first collect the data, pre-process it with a diverse data set of healthy and disease plants images, train the CNN model, and then we will accurately classify the Lufa disease symptoms according to the classes, and where we will also check the model's accuracy, robustness, and generalizability before we have a final validation confirmed. So we have built a project using TensorFlow where we will capture the images using a web app developed with React Native to identify the diseases with the highest accuracy. We had a comprehensive dataset of both healthy and diseased liver plants, which were helpful in developing our model. Here we have also prioritized our accuracy, the robustness, and the model working so then we can have a final validation. This is the model work architecture. Ritik will also explain it very nicely, but as a basic layer we can say is we take the images, we clean them, pre-process them, with the data augmentation, then we build the model of a CNN where and then our model was made. Then fast API where we had our local host and then the web app was developed using React.js and then we connected the both local host and the React Native where we did the backend and frontend connect and then we have our model ready with the frontend. The pros and cons of the model were that the pros is that we have an increased yield because we have a timely intervention and prevention of this symptom, and this would also help in reduce pesticide because early intervention will help to remove those leaves or to prevent it. But the con is that there's a major overdependence on technology which can lead to a little decrease in the traditional methods. Now I would like Ritik to take over and explain you the web app properly. Thank you.
As you can see, here is a main file that is the backend of the web app, and here the front end file is the front end part. So we have already ran both the files. Here you can see there's a node file npm start that we have used here to run it, and this is the Python file. Now we go to our web app. This is running on localhost 3000. You select on the data set. Now you select any of the image and then we predict. As you witness, we have got a confidence of 99.90% and the label is Alternia as we have intended to. It's a correct prediction. Thank you.